Cross-laminated timber, CLT, is thought by some to be the building material of the future. With known environmental, safety, and price benefits over typical steel construction, CLT offers incredible benefits over standard building materials. Cross-laminated timber is made by gluing pieces of solid wood at perpendicular angles to each other with construction adhesive. This manufacturing process allows CLT to perform under much higher levels of stress than typical wood beams. This added strength also allows CLT to be used in bigger scale construction than typical wood beams. There are many environmental benefits to using CLT over traditional construction materials. Wood is the only major building material that grows naturally and is renewable. Structures using CLT are more energy efficient, as the wood panels are effective insulators and reduce potential air leaks. CLT buildings require only 1/3 of the normal amount of heating or cooling as opposed to structures made with traditional building materials. CLT also has a lighter carbon footprint, as the wood manufacturing process requires less energy than materials like concrete or steel. On the job site, CLT panels have little to no waste, as they can be repurposed for other construction projects or used as biofuel. In comparison, concrete and steel create a lot more waste and use a lot more energy in production and installation. There are many benefits to using CLT as opposed to steel or concrete. CLT is extremely durable by design and can be altered accordingly by simply increasing the thickness of the panels in the fabrication process. Seismic tests have also proved the lateral stability of CLT. In addition, CLT can be used in walls, roofs, stairs, and in structural applications, making it a diverse resource. CLT's incredible strength-to-weight ratio and design flexibility provides many financial benefits. Since the timber is prefabricated, it arrives at the job site ready for assembly, which can reduce job time and in turn reduce costs. Furthermore, the lightweight nature of the material means travel expenses can be reduced, as more can be transported and job-like site applications can require less labor. Finding a prime example of the application of CLT takes you no further than UMass's own John Over Design Building. The Over Design Building boasts being the first and largest CLT academic building in the United States. This beautiful building shows off the true potential of cross-laminated timber. With its 4-story, 87,000 square foot footprint, this hybrid CLT and steel building construction classroom building demonstrates CLT to its fullest potential. Opting to choose the likes of cross-laminated timber as the structural material for the design building allowed for this classroom building to not only have reduced carbon emissions during the construction process, but additionally allowed for the preservation of rare earth metals from not having to mine as much steel for the frame of the building. These factors made this project a very green endeavor for our university. CLT buildings in the U.S. are still at a very young stage in their development. As latecomers in implementing this new material, there is much future innovation that is in the works for the United States. The McMurray National Airport is a prime example of the capabilities and scope of CLT that the U.S. has seemingly not unlocked yet. This amazing CLT structure is erected in Canada. Here, temperatures can drop as low as -40 degrees Celsius in the winter and rise up to 30 degrees Celsius in the summer. This building, though wood, easily sustains itself in these grueling conditions. A building in these conditions shows the abuse and stress that can be sustained and maintained with the use of CLT as a building material. CLT has a bright future, one full of many environmental and copious other benefits. We hope that builders will start taking a closer look at this technology and start to utilize it more in upcoming years and hopefully, eventually, completely convert to the use of CLT instead of steel in modern construction projects.